Okay, so the first thing I want to do today is just one more example for your notes of how to graph these guys with multiple shifts, okay? So looking on the back side of your notes, you have that second problem there at the top, okay, the second example there. We're going to work this guy together. All right, so finding the vertex of these is exactly the same as finding the vertex of absolute values, the same as finding vertex of square roots. So our vertex here is going to be listed where? -2, -5. Remember that x is hexed, y is y's. Okay, x is hexed, y is y's. So it's -2 and -5. So that translates to a shift where we go left 2, down 5. Well, we also can find our axis of symmetry here. So our axis of symmetry is x equals what? -2. It comes from the x coordinate of our vertex. Okay, well, to find a maximum or minimum, we have to decide, is this graph opening up or is it opening down? How do we decide? The A value. The A value sitting right out in front, that first number there tells us up or down. If it's positive, it's up. If it's negative, it opens down. Ours is positive, so this opens up. So since this opens up, we have which? A max or a min? We have a minimum. So our minimum value is -5. It's that y value of our vertex. All right, so we have all that good information. The next thing we need to do is we need to make a t-chart. And for our t-chart, we always use the numbers -2, -1, 0, 1, and 2. Looking back at the equation, for the t-chart, we want to graph that without any shift. So you ignore the numbers that gave us the shift. I cross them out. So I only want to plot points for y equals 2x squared. Okay, well, we plug into that. Y equals 2 times x squared. Well, let's say x is -2. What's -2 squared? 4. And then 4 times 2? 8. All right, well then what is -1 squared? 1. 2 times 1? 2. What is 0 squared? 0 times 2? 0. Well, now this should just repeat those same numbers, right? Let's just verify that it happens. If I plug in 1, 1 squared is 1, 2 times 1 is 2, like we thought it should be. It has to be symmetrical. If I plug in 2, 2 squared is 4, and 2 times 4 is 8. So yes, it is symmetrical. It does give me those numbers back again. All right, looking at the graph. These values in our t-chart are before the shift. So I graph those with just little x's. So if I'm at -2, I'm up 8. -1, up 2. 0, 0, 1, 2, and 2, 8. So each one of those points now needs to be shifted left 2, down 5. And from that, you can draw your parabola. Questions? Okay, so today we're going to continue on dealing with parabolas, but rather than just graphing them, we want to go through and practice writing their equations. Okay, we saw this before with absolute values and with square roots, where I gave you a graph and said, what's the equation of that graph, right? Well, we're going to do the same thing here. So, I have written a couple extra examples here. So, on your graph, if you would like to copy down my graph, that's fine, but more importantly, if you're just doing it on a scratch sheet of paper, I want you to copy down the points that I use, okay? So, pay close attention to where I get my points from. Then all you need to do is write down those points and then work the rest of the problem with me, okay? So if I give you this graph, things that we need to know, first off, you just need to know what is your equation you're working with. What is vertex form? Well, that's y equals a times x minus h squared plus k. We want to write the equation of this parabola in vertex form. So to do that, we need to know the vertex. Well, our vertex is located at 0, 0. Then the other thing we need to do is we're going to need it, because we've now filled in h and k, we need to know what a is, okay? The issue here is that there's no way of looking at our graph and deciding what a is. Okay, it's not like absolute values where we can count the slope of the right side and know what a is, okay? So what we need to do is we actually need to find a second point. Now, on this graph, I've given you 4 other points, so we just get to pick one. So let's go ahead and just pick the next one here. Okay, so the coordinate of that point, I'm just going to call it P for another point, is at 1, 2. Okay, so using my graph, I have found the vertex, and I have found just a second point. Right? I could have used any of those 4 points, but I just chose to use 1, 2. Okay? Well, what we've done then is we have found h and k, and the point gives us an x and a y. So we have found a value for everything in that equation except a, which is what we need to find. That's the missing piece to be able to write the equation here. So we can plug in everything we know and solve for a using algebra. So remember that this point here, the vertex, gives us h and k. And then the point we found gives us x and y. And remember, it's always in those orders, right? So therefore, 2 equals a times 1 minus 0 squared plus 0. So 2 equals a times 1 squared is what we have. Well, what is 1 squared? 1. What's 1 times a? A. So a must equal 2. We can use that information. We can use our vertex to plug in to our final equation here. So y equals 2 times x minus 0 squared plus 0. Do I need the zeros there? No. Nope. So there's the equation of this parabola. Y equals 2x squared. Example 2. Again, I give you a parabola. The vertex form y equals a times x minus h squared plus k. We need to find our vertex, which looks like it's located where? 2, 3. We need to find some other point. Doesn't matter what other point you use. I've given you 2 other points as options. Which one do you want to use? 0, 1. All right, we take those values. We plug in the vertex for h and k. We plug in the point for x and y. and we're then going to be able to solve for a. So 1 equals a times 0 minus 2 squared plus 3. Well, 0 minus 2 is negative 2. What's negative 2 squared? So we have 4a plus 3. We need to solve for a. So it looks like I subtract 3 from both sides. Divide by 4. Negative 2/4 reduces down to what? Negative 1/2. Okay, we want to double check something. Remember, the a value tells us if we open up or down, right? Does our a value match the graph? Yeah, our a value is negative and our graph opens down, so that's a good check. Okay, that's a good check. All right, so we got to plug in our a value and plug in our vertex to find our equation. So y equals negative 1/2 times x minus 2 squared plus 3. There's nothing in that equation that we need to reduce or simplify, so that's our answer. That's the equation of this parabola. Questions? Okay, example 3. Once in a while, they're just going to give you a couple of points. They're not even going to give you the graph. But then again, was the graph needed? No, not really. We needed those points. So again, this is going to be a situation where we just plug into our vertex form. So I'm going to speed this up a little bit. Knowing those values, I can plug directly into vertex form. 3 equals a times x. X is 0 minus 2 squared plus a negative 1. Well, 0 minus 2 is negative 2. Negative 2 squared is 4. So I have 4a minus 1. Add 1 to both sides. 4 equals 4a. I bet you know what a is going to be now. So a must equal 1. All right. So y equals 1 times x minus 2 squared plus a negative 1. The only simplifying I would do here is the fact I don't need to have that 1 out in front. 1 times anything is just that thing, so I don't need the 1. And I would change plus a negative to just minus 1. Okay, so my final answer is y equals x minus 2 squared minus 1.